get started after doing this. That is expectation of x, but here gx is equal to x square. There was gx, that is xi, and now x gxi is equal to x square. Ex square is equal to nothing but gxi pi, or you can write it gxi p capi x small xi. So gxi is x square here and pi, so you can write it as x square p capi x is equal to xi. So here we can form a new notation, that is v, and that is variance. Variance is equal to e x square minus e square x. Now what is e square x? We can form ex, that is summation xi and px is equal to xi, or you can write it as ex is equal to summation xi pxi, sorry, pi. And what is x, and e square is nothing but e square, that is ex, e square x. So another concept is mass point, that is very important concept of probability distribution. And what is mass point? Mass point is that where when a mass point is actually means non-zero probability. What is non-zero probability? Non-zero probability is this is y-axis, and along this we can measure probability, and this is x-axis, along this we are going to measure x. This is 1, 2, 3, 4, 5, and the tossing of, let's say there is no tossing, let's say x takes values 0, 2, 3 with probability 1 by 2, with probability wp 1 by 4, and with probability 1 by 4. And now we are going to draw these values here, these one, these one, and these one. Here we can see there is no zero probability, there is no zero probability, so we can confirm it as mass point. We can say this as mass point. X takes any value here. So we are going to another example. If a fair coin, I am going to say the questions in vocal, after otherwise this video is going to be long. If a fair coin, okay, I will write it, tossed twice, there is no zero probability, no, sorry, the number of heads, sorry, number of heads is denoted by x will have the following probability distribution. So let's get started with this example. values x, p of x capi X is equal to x I or x small x, 0, 1 by 4, 1, 1 by 2, 2, 1 by 4, and this is total. We know the probability is always 1. The value of probability of anything is always 1. And now we are going to know the sample space of this probability distribution is. How can we form this? A fair coin is tossed twice and number of heads. So there is two outcome and this is twice tossed. This is tossed twice. So the sample space always be 4. If we toss this thrice, what will be? Number of outcomes to the power 3. This is thrice. And this is nothing but 8. The sample space is HH, comma, HT, TH, TT. And now capi X is equal to 0 is TT, because X takes number of heads. X takes the value number of X number of heads. Okay, probability this. X is equal to 1 HT TH. Sorry, I have to write this here. And now the probability of these X is equal to 1 P HT TH. Sorry, HT comma TH. And now the probability is written by HT plus TH. 1 by 4 plus 1 by 4, 2 by 4, that is 1 by 2. So here we got these things. And I have to find another one that is nothing but X is equal to 2. Say what will be X is equal to 2? In the sample space, 2 head, find it. The number of 2 head, that is HH, and write it down here as simple as that. So HH means the probability of X is equal to 2, the probability of HH 1 by 4. And there we go, we are going to know the another example. Why expectation is known as the mean? I have said this before, this is nothing but mean. But why? 1 by n, what is the formula of mean? 1 by n summation xi. Here I is running from 1 to n. This is for non-frequency data. And if we see for frequency data, that will be 1 by capi n summation xi fi n 1 I runs from 1 to n. And what will be the n? That is summation fi. All values of frequency is added to get n. So, so n can be denoted, and now we can write this as this form. Now we can see this is all possible outcomes, and this is favorable case. This actually speaks about probability. What does probability says? Everybody knows probability says number of outcomes, number of favorable case, right? And from these we can illustrate this is nothing but probability. And now if there is there we can ask another question. n If n is tends to infinity and probability is ai, where ai is distribution of the category and what does it denotes? This denotes n is extremely large, right? And the values you can see you are not going to get these facilities here that I am taking. However, values x and fi 20 to 40, 40 to 60 and 60 to 80, and this is f1, f2, f3, and probability of getting marks in 40 to 60. Marks means these values. This actually speaks about the marks. And this is denoted by AI. This is not artificial intelligence, lol. This is like AI and is equal to fi by n. All possible favorable case, and this is all possible outcomes. So here here this is solved by this. After that here means summation I runs from 1 to k, and this is xi fi by n, and n is extremely large, that is k is replaced by infinity, infinity, and I runs from 1 to infinity. So infinity I is equal to 1 xi pi is equal to ex. This is expectation. That is why we are saying expectation of x is nothing but mean. So everybody, here ends this session. Stay tuned for the next part. Thank you.